Question 2. Figure 1 shows the label from a box containing radium-226. Radium-226 emits alpha, beta and gamma radiation. Okay, so this is the picture. Figure 2 shows how the activity of the radium-226 will change. And there's a graph there, looks like our classic kind of decay graph. So straight away I'm thinking, well, I'm probably going to have to find the half-life for this source. And what does the question say? It says, determine the half-life, okay, of radium-226. Show you're working on figure 2. Okay, so figure 2 is the graph, and it's worth 2 marks. So for this question, I have to show some working on here. It may well have said use figure 2, in which case I still really have to write on that diagram as well. So the half-life. So I'm going to start off with, I'm going to find a nice easy number to begin at. So here we go, I'm going to begin at 180, it's quite a straightforward one there. So that's 180 at the start. Half of that will be 90, not 1000, because that's half of 180. Draw a line across from that till I hit the line, and then draw a line down vertically. To there, that's going to be, my graph's a bit hard to see here, but 1, 2, 3, 4, 5, 6, 7. That's about 1,700. And what I can do then is I can do another line just to check that I'm happy with that. So half of, well, in fact, let's pick a different one entirely. Let's go for 40,000 here. That'll take me out to there. So 40,000. It's always worth doing 2 just to check. So 40,000 and half of 40,000. So that's 1, 2, 3, 4, 5, 6. That's 3,600. So I'm expecting this, the next half-life to be, if its half-life is always 1,700. Half-life, remember, has got symbol T half, so 1700. I'm expecting another 1700 later to hit half of 40,000, so that's 20,000. Let's just see where that line takes us. To there, and we'll draw a line down there. I'm hoping what's 3,600 plus 1,700 should take us to 5,300. Let's see, 1, 2, 3, perfect. 5,300, which means the gap between there and there is also 1,700. Okay, so I'm confident now that 1,700 is the answer, because the gap, if I start with half, remember, if I start with a whole, sorry, I've got a half of that, takes us to here. So half of 1,800 is 90,000, and here I started at 40,000, and I'm going to go to half of that is 20,000. So the time it takes to get from the whole to half will always be 1,700. Okay, so 1,700 years. If you only did one set of lines, that might be okay. Okay, it might be okay. Personally, I would always go for at least 2. If this graph was a little easier, I would have gone for 45,000, but the graph's a little bit hard to see on my graph where 45,000 is. I've just halved that 90 again to get down to there. Personally as well, I'd always start from the 0 time to do your first one, because it's much easier. You don't need to worry about sort of taking away then. Okay, part B. So part B, radium-226 was discovered by Marie Curie in 1898. The notebooks she used were contaminated with radium. and are still hazardous. So explain why her notes are still hazardous. So explain is a describe plus, it's worth 2 marks, 1, 2, so it's a describe plus. Why are they hazardous? They're contaminated with radon-226. Okay, we know that the half-life is high. The half-life is 1,700. So that was 1898. So only, how far is that? So so less than 200. It's been less than 200 years. So it's been less than 200 years since contamination. Okay, that's the describe bit. I'm just saying how long ago it happened. I can also describe the half-life of radium is 1,700 years. Now, if I didn't know that, or if I wasn't sure my answer was correct, I could always say half-life of radium is much higher. That'd be fine. This means the activity of the radium is still high. Okay, because there's still lots of it on there. Okay.